Hello dear students, I hope you all are fine and doing well in your studies. Students, today we are going to start with a new chapter, that is chapter number 9 included in NCERT, and its name is Sequences and Series. As far as the weightage of this chapter is concerned, this chapter is going to fetch you 4 marks in JEE mains exam because every year at least one question is being asked from this section. And as far as today's particular session is concerned, we are going to study about the basic keywords. That is, what is the meaning of sequence, what is the meaning of series, what is the meaning of progression, what is the difference between a sequence and progression, and along with some examples. So let's get started with the very first lecture of sequence and series. So let us first understand the meaning of these important keywords, that is sequence, series and progression. So we have sequence. What is the meaning of the word sequence? Now, right from your earlier classes, you must have been acquainted with so many sequences. Like, for example, I can have 2, 4, 6, 8, 10, and now over here I place a question mark. And if I ask you that what will be the number after 10 in this sequence, so you can easily say that between two consecutive numbers, there's a difference of 2. So basically this number over here is going to be nothing but 12 itself. Why? Because if I add the number 2 in 10, we are going to get the another number of this sequence. So this is an example of a sequence. Why? Because I have written all the numbers corresponding to a logical rule. Similarly, I can have a sequence like 2, 3, 5, 7, 11, 13, 17 and so on. So this is also going to be a sequence because we are following a logical rule, and that logical rule is that all the numbers present over here are prime numbers and all the numbers present over here were even natural numbers. So one must pay attention that any sequence will follow a logical rule, but it is not compulsory that there is going to be a general formula of that logical rule so that we can arrive to the nth term or general term of that sequence. Alright, so basically we have defined sequence in this way that it is a function whose domain is the set of natural numbers or some subset of it. So for us, sequence is going to be a function whose domain is the set of natural numbers. Why set of natural numbers? Let me tell you that if we have fn equals to n square plus 1, now if I have to put the values of n in order to get the terms of the sequence, then I can put the values of n as 1 for the first term, 2 for the second term, 3 for the third term, 4 for the fourth term and so on. Alright, if I put n equals to 1, I am going to get f1 or f of 1 equals to 1 square plus 1, and this is equal to 2. If I calculate f of 2, this is equal to 2 square plus 1, which is further equal to 5. If I calculate f of 3, this is equal to 3 square plus 1, which is 10. If I calculate f of 4, this will be 4 square plus 1, and this is further equal to 17. So according to this functional rule fn is equal to n square plus 1, I can get each and every term satisfying this rule. Alright, but here I cannot put the value of n equals to minus 1. Now this is not permissible. Why? Because there is no such term called as the minus 1th term. The term can be first, second, third, fourth and so on, but there is no such term called as the minus 1th term or half term or 0th term. No such term is going to exist in a sequence. That is why our sequence is a function whose domain is the set of natural numbers or some subset of it. If I take the values of n from 1 to 4, then 1 to 4 is the subset of natural numbers. And you all must be aware of the fact that set of natural numbers is denoted by capital N. Alright, so here I have written down a general formula of a sequence, which is in the form of a function whose domain is the set of natural numbers. So I hope everybody must have understood what is the meaning of a sequence. So according to this given definition, I can write it down as, if we define a function from the set of natural numbers to the set of real numbers, then domain is the set of natural numbers, and if we put the values of n equals to 1, 2, 3, 4 and so on, we are going to get each term of the sequence. So this set over here is representing the terms of the sequence defined by f. Alright, so I can write it down f of 1, f of 2, f of 3, f of 4 and so on, or this can be also written as t1, t2, t3. Here lower subscript represents the position of the term, or I can also write it down in the form of a1, a2, a3. So in general, the general term of any sequence can be written in the form of f of n or t of n or a of n. This is the symbol of equivalency. So f of n is equivalent to t of n, which is further equivalent to a n. This represents general term of any sequence. Alright students, we are now in a position to understand the word series. What is the meaning of the word series? Consider that we have a sequence in which terms are given in this way: a1, a2, a3, a4 and this continues till an. So these are the terms of a sequence. So if I add or subtract these terms, then the resulting expression is going to be called a series. Alright, so the definition of series becomes, by adding or subtracting the terms of a sequence, we get an expression which is called the series. So I can write down a series in this way, or in this way. Right, here I have added and here I have written them down, or we can add a1 with minus a2, then a3, then minus a4 has been added. In any way you can say. So this is also a series. Alright, so you can either add all the terms of a sequence or even you can subtract the terms of a sequence. In both the cases, the resulting expression, this expression, will be called as a series. Now there is another compact way to represent a series. There is a compact way in which we can write down a series, we can indicate a series. How? Consider this series where I have added all the terms of the sequence. Now this can be represented by sigma ai, where I varies from 1 to n. Alright, so this is the compact notation that I am talking about. This compact notation is denoted by sigma, which means that whatever has been written inside it, we have to add them up in order to get the entire series. So if I put I equals to 1 over here, this becomes a1. If I put I equals to 2 over here, this becomes a2. If I put I equals to 3 over here, this becomes a3. So 1 to n, we can put 1, 2, 3, 4, 5 up till n. So if I substitute all the values of I in this particular general term, and due to this sigma, if I add them up, what I am going to get? Going to get the series that has been written over here in LHS. So basically, this is the compact way of denoting a series. Alright, let's move further and understand the word progression. Now the word progression simply refers to the sequence or series. It is referred with the help of a sequence or a series. Now there is a basic difference between progression and the word sequence. And the difference worth noting is that a progression always have a definite formula, but a sequence may or may not have a definite or general formula. Alright, like earlier we had taken an example that if I write down the numbers such as 2, 4, 6, 8, 10 and so on, so there is going to be a general formula corresponding to these terms, and that general formula will be 2n, where n has to be greater than or equal to 1, and again n has to be natural. If I substitute the values of n which are greater than or equal to 1 and which are natural in this general term, I am going to get the entire this sequence. I am going to get these terms. Alright, but if we talk about the prime numbers, now we know that this is a sequence of prime numbers, but there is no such general formula by which I can write down each and every term, or by which each and every term can be indicated. Alright, so please make a note that this is a sequence but not a progression. This is a sequence but not a progression, while this over here is also a sequence and a progression. So this is what I am trying to say, that there is a simple difference between progression and sequence, that a progression is always governed by a definite formula so that we can derive each and every term and we can write down the general term of that progression, but a sequence may or may not have a definite formula. Alright, like in case of prime numbers, this is a sequence. So I hope you people have understood the meaning of sequence, series and progression. Alright, so let's do a couple of questions that are based on sequence and the general terms of a sequence. So here we have a question that says, write the first 5 terms of the sequences whose nth terms are. First part says an is equal to n into n plus 2, and in second part an is equal to 2 raised to the power n, and in third part an equals to minus 1 raised to the power n minus 1 multiplied by 5 raised to the power of n plus 1. So for the first part, when an or general term is given by n multiplied by n plus 2, now since we have to determine the first 5 terms of the sequence, what we are going to do? We are going to substitute the values of n as 1, 2, 3, 4 and 5 in order to get the 5 terms of the sequence. So for a1, n has to be equal to 1. So if I substitute n equals to 1 over here, I am going to substitute n equals to 1 over here as well. So this becomes 1 into 3, which is 3. For second term, n is going to be 2. So this becomes 2 multiplied by 4 and this is equal to 8. For third term, n is 3. So we get a3 as 3 multiplied by 5, which is 15. For fourth term, n equals to 4. So we get a4 equals to 4 into 6, which is 24. And for the fifth term, n equals to 5, corresponding to which a5 is 5 into 7, which is 35. Alright. So the terms of this sequence are 3, 8, 15, 24 and 35 in order. Alright. Now second part. For second part, the general term has been given as an equals to 2 raised to the power n. Now again we are going to substitute the values of n in order to get the first 5 terms. So for the first term, n is equal to 1. So we get a1 equals to 2. When n is equal to 2, we get second term as 2 square, which is 4. When n equals to 3, we get third term as 2 cube, which is equal to 8. When n equals 4, we get fourth term 2 raised to the power 4, and this is 16. And the last term, that is the fifth term, is obtained by substituting n equals to 5, and this is equal to 32. So the terms of this sequence are going to be 2, 4, 8, 16 and 32. Alright, let's crack the third part. Third part says an is minus 1 raised to the power n minus 1, 5 raised to the power n plus 1. So general term has been given in this way. Again, for determining the first 5 terms of the sequence, we are going to plug in the values of n from 1 to 5 in the general term in both the sides. So when n is equal to 1, we get first term as minus 1 raised to the power, this becomes 0, and 5 raised to the power 1. So this is equal to 5. When n equals to 2, we get the second term, minus 1 raised to the power 1 and 5 raised to the power 3. So this is minus 125. When n equals to 3, we get third term as minus 1 ka square and multiplied by 5 raised to the power 4. So this is 625. Similarly, n equals to 4 and n equals to 5 के corresponding minus 1 whole raised to the power 3 and 5 raised to the power 5. And fifth term is going to be minus 1 whole raised to the power 4, 5 raised to the power of 6. So this is equal to minus 3125 and this one is equal to 15,625. Alright, so we are done with finding the 5 terms of these respective sequences. So these are very simpler kind of problems. I hope everybody must have understood so far. Next problem says the Fibonacci sequence. Now this is a very famous sequence called as Fibonacci sequence, and this is defined by a1 and a2 equals to 1. So the first 2 terms of this sequence is equal to 1 and an is given by an minus 1 plus an minus 2 where n is greater than 2. So the general term of this sequence is an equals to an minus 1 plus an minus 2 where n is greater than 2. So find an plus 1 over an for n equals to 1, 2, 3, 4, 5. So since we have to find an plus 1 over an for n equals to 1, 2, 3, 4, 5, if I put n equals to 1 over here, we have to find a2 by a1, then we have to find a3 by a2, then a4 by a3, a5 by a4 and a6 by a5. So basically we have to find the values of these ratios. So for this we will have to determine all the terms from 1 to 6. Alright. So let's calculate each and every term from this general formula. Since n is greater than 3, I can plug in n equals to 3. I can start with n equals to 3. So a3 becomes equal to a2 plus a1. Alright, we have substituted n equals to 3 over here, and also over here. So a3 becomes a2 plus a1, and a2 and a1 both are equal to 1. So this is equal to 2. So third term is 2. Now if we substitute n equals to 4, we get a4 as the sum of a3 and a2, and a3 is equal to 2, a2 is equal to 1. So adding up gives us 3. So the fourth term is equal to 3. Now we substitute n equals to 5. So a5 is a4 plus a3, which means 2 plus 3, and 2 plus 3 is equal to 5. So fifth term is going to be 5. And now for the sixth term, n equals to 6. So a6 is a5 plus a4. So we have to add 3 and 5, which gives us 8 as the sixth term of this sequence. 1 plus 1 will give you this number 2, and then 1 plus 2 will give you this number 3, then 2 plus 3 will give you this number 5, then 3 plus 5 will give you this number 8. So this sequence is Fibonacci sequence. So now we have a1, a2, a3, a4, a5 and a6. Just plug in these values in order to get these ratios. So a2 upon a1 becomes 1, a3 upon a2 becomes 2, and a4 by a3 becomes 3 by 2, a5 by a4 becomes 5 by 3, and a6 upon a5 becomes 8 by 5. So I hope you all must have understood everything that we learned in this particular lecture. So we are going to continue further with the progression, and we are going to study about all the progressions, that is arithmetic, geometric and harmonic progressions, in our upcoming lectures. So this is it for today's lecture. See you in the next lecture.